Okay, so the name of the section is Solving Rational Equations and Inequalities. This is section 7.6, Algebra 2, page 508. And rational equations and inequalities. That's a word we need to look at. Rational equations. Rational equations, whoa. Rational equations, rational inequalities. Rational is a fraction. So what we do is we have fractions. But the problem is we have fractions. We have fractions. Sorry, let me adjust this real quick. We have fractions in the numerator and the denominator that we have to get rid of. In this case, today we're going to talk about fractions in the denominator. Okay? And inequalities will be the same. They're done. They start out the same way. However, you have to do some different things with inequalities that you don't have to do with equations. Okay? Keep in mind, guys, that you have a variable in the denominator. So you always have to be aware of whatever makes your denominator 0. If you have something that makes your denominator 0, you cannot use that answer. You understand that? And that goes with the first inequality, or the first equation. So let me take a look here. The directions will be to solve. That's what we're solving for. We're solving for a variable. And it looks something like this. Okay, this is a rational equation. It has a variable in the denominator. I know that most of you do not like fractions, so there's an easy way out of this. You multiply by what we call the LCD. Does anybody know what that stands for? Least common denominator. In this case, our LCD, and this is what happens to a lot of students, is how do I decide what my LCD is? You make sure that the denominator is factored, and then you multiply by all the largest factors that you can. So 6 and 18, the largest multiple is 18. 6 goes into 18. And then you have an x plus 3. So I'm going to multiply all three of these by this. Now, one mistake, and you're not going to see this as a mistake, is I'm going to multiply all 3 times this. And I have students that skip this step or try to skip this step because they don't want to write all this down. And I get that. However, I see a lot of mistakes when they don't write this down. I am multiplying, and remember, it's really like over 1. You can put it over 1 if you want, but this is all over 1. See, Art?
Please excuse the interruption. Would you please dismiss the golf team at this time?
Have fun.
Thank you.
Yep. Okay, so in this case now, what happens is this denominator and this denominator cancel. Okay, leaving us 18 times 4, which is 72.
Yeah.
Okay, now folks, can you just offhand before we go much further, can you tell me what value of x that you cannot have?
-3.
-3. So when we get our answers, let's make sure that -3 is not one of them. All right, so now this cancels, the 6 cancels with the 18. Is that correct? We have 3. We also have a 5 here. Don't forget that. See, it's over here. We can't cancel that with anything. So this is really 15 times this. You understand that? So it's 15x plus 45. CJ, did you see that?
Yeah.
Okay, don't forget there's a 5 over here. Now the 18s cancel, and I have, that is what, 23 times x plus 3, so 23x plus 69, is that right? Okay. So these two are like, so I'll put those together. That'd be 7 and what, 117, is that correct?
Yeah.
Plus 15x equals 23x plus 69. I'm going to subtract 15x from both sides, get my x's on one side. Whoops, sorry, tried to divide it there. minus 15x, and I get 117 equals 8x plus 69. Now subtract 69, and I get 8x equals, what, 8? 48, is that correct? And divide by 8, and divide by 8, x equals 6. Now, 6 is not 3, correct? Therefore, that is your answer. Do you have a question, Dawson? No. Okay. Any questions then? Okay. All right, let's take a look then, and we can go a little bit deeper than that. Let's take a look at number 2. The directions are still solve. We have 2x over x plus 5 minus an x squared minus x minus 10 over x squared plus 8x plus 15. Is that correct? Okay, equals 3 over x plus 3. Okay, if you look, this one can be factored, the bottom has to be factored before you do anything.
Was the top also?
You might want to, so let's just look at it, see if anything can cancel, because if they can cancel, that'd be great, wouldn't it? All right, remember this is a subtraction sign, so I think it's x minus 5 times x plus 2, is that correct?
Yeah.
And on the bottom it's x plus 5 and x minus 3. So that was a bust, wasn't it?
X plus 2.
Yeah. It was a bust because you can't cancel anything. So we good? So you're going to be weirded out, but in a minute I'm going to put this back to the way it was because it's actually easier to multiply when it's the other one. Okay? So now I'm going to multiply by the LCD, which is what?
X plus 3.
That is correct. This is the LCD. Oops, that's plus 3. So I have the quantity x plus 5 times x plus 3 over 1. You can, however you want to do it, times 2x over x plus 5 minus x plus 5 x times plus 3 over 1 times, are we okay?
How did you get x minus 5 and x plus 2 on the top?
I factored this.
How does that factor into that?
Oh, it doesn't. That's not factorable, is it? I was thinking that was 3. Sorry, you're right. Thank you. So it's, I don't think it can be factored, can it?
No.
So let's leave it. I was going to put it back anyway. You know what I'm saying?
Yeah.
Because it's just easier to work with. And then I got to multiply it by the right side also. Okay, it's a lot of writing. I understand that. I get that. I just think it works better if you do it like that. Okay, so now we're going to cancel. You ready? Yes?
Yes.
Okay, so this cancels with this. You see that? No. I'm sorry. I got the wrong one. This is x plus 5, isn't it? Yeah. This is x plus 3. Can't read my writing. So this cancels with that. There we go. Much better. I'm going to take 2x times that. So I have 2x squared plus 6x. Do you agree? if I distribute it through, correct? That's a 3. Now, minus, and I'm going to do a quantity here. This cancels with this, and this cancels with that. So now it's minus x squared minus x minus 10. Why did I keep it as a quantity?
So you can cancel.
No, so I could bring the minus sign throughout all of them. Okay? And then the x plus 3 cancels here, so I have 3x plus 15. Any questions?
The middle one?
Yep, this one here, right here.
Okay, so they both cancel. Okay.
Yes, they both cancel. Questions? Okay, so I'm going to bring the minus sign through, so I have 2x squared plus 6x minus x squared plus a positive x plus 10 equals 3x plus 15. So 2x squared minus x squared is 1x squared. 6x plus that is 7x plus 10 equals 3x plus 15. All I'm doing is simplifying here. Now I'm going to put everything on the left side and try to factor it because I have an x squared term. I'll say that again. I'm going to move everything to the left side and try factoring it because I have an x squared term. So I'm going to subtract 3x from both sides. So now I have x squared plus 4x plus 10 equals 15, and I'm going to subtract 15 from both sides. So I end up getting x squared plus 4x minus 5 equals 0. And I want to try to factor this. Now you told me at the beginning, or no, I guess I didn't ask on this one, what are the two values you cannot use?
Negative 5, 3.
Negative 5 and a negative 3. Okay, so let's factor this. So it should be x plus 5 times x minus 1 equals 0. So my two possible answers are a negative 5 and 1. But Bo told me that a negative 5 could not be used. Why?
Because it was in the denominator.
That's right. So this is out. My answer is 1. Is it possible that none of your roots will work?
Yes.
Yes, it is possible. And then you just write no solution. CJ, do you have a question?
I was wondering. Never mind. I got it.
You got it? Questions? All right. Now, inequality is a whole different ballgame, and this is where students get in trouble because they think that it works kind of the same way. It starts out the same, but then some things change. Okay, if you look on page 513, there's some steps to doing a rational inequality. So that's what we're going to concentrate now on, rational inequality. First of all, step 1 is to state the excluded values. These are values for which the denominator is 0. Solve the related equation. Use the values determined from the previous steps to divide the number line into intervals. Test the value in each interval and determine which intervals contains the values that satisfy the inequality. We're going to use a number line. That's totally different, isn't it? Yeah. On that number line, we're going to find boundaries. Then we're going to test the areas that the boundaries separate. So you're going to have more than one answer, possibly. Okay? All right. So let's take a look here. The directions will still say solve. I'm on 3, correct?
Yes.
So you have x over 3 minus 1 over x minus 2 is less than x plus 1 over 4. Okay? Now the first thing we have to do is the excluded values are 2, correct? 2 is the only one?
Mm-hmm.
Okay, so the excluded value is just 2.
That means that's just saying
It means you cannot use
So
it.
x cannot equal 2.
Right. Excluded means it's gone. It can't be used. All right. The next thing we're going to do is we're going to solve. We're going to put an equal sign in here and solve for what x is. So we're going to replace the inequality with an equal sign, and that's number step. Solve the related equation. This is called a related equation. Related means that we simply take the inequality symbol, we put an equal sign. Okay? You got it? Now we multiply by the least common denominator, just like we did before. So we do the LCD, multiply by the LCD, which is what?
12.
12x minus 2.
Why is it 12?
Because you have a 3 and a 4.
Okay.
And the multiple between 3 and 4 is 12. I'm going to run out of room here. I'm going to erase this. Okay. Is that true? All right. Now we cancel. So this is 4. So I have, and don't forget this x. See this x right here? This is 4. So I have 4x. So I have 4x squared minus 8x. Does everybody see that? This x and that 4 is 4x. 4x squared minus 8x. Minus, this cancels with this. So I just have 12 remaining. And 12 times 1 is 12. We good?
How'd you get it? Minus 8.
Because I took 4x squared,
never mind.
4 times 2, I distributed it.
Okay,
And then this is 3, and now I got to FOIL that and take 3 times it. So x squared, this is a what? I can't read my writing. It's x minus 2. Thank you. So negative 2x and 1x is a negative x minus 2, correct? I hope that's right. Is that true? So if I bring the 3 through, it's 3x squared minus 3x minus 2. Ooh, 6. Minus 6. And now I'm going to put it all on one side. So I'm going to subtract 3x from both sides. I get x squared. I'm going to subtract a negative 3x, which is the same as adding 3x. Is that right? And that would be minus 5x. And then I'm going to add 6 to both sides. It's minus 6. Notice how I did all 3 at the same time. Sorry about that. Now, if I factor this, I get x minus 6 times x plus 1, correct? So my two values are 6 and a negative 1. Now, if this was a true equation, these would be my answers because they do not match the excluded value of a negative 2, or of 2. They're not. And inequality is different. Okay, so what we do is we create a number line and we put all 3 of these values on there. So I have 3 values ranging from a negative 1 to 6. We go a negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. Do you all agree? What I did was I'm going to put all 3 values on here. All 3.
What's the third one?
2 was my excluded value. Okay? So let's begin with that one, Bo. An excluded value has a dashed line. And the reason it has a dashed line, Bo, is because it cannot be 2. So dash means cannot be that. All right? Now the other 2, if this was less than or equal to, if this was less than or equal to or greater than or equal to, these would have solid lines. But since it's just less than, these also have dashed lines. Does everybody understand that? The excluded value always has a dashed line. The other 2 would have a solid line if I had an equal sign here with the less than or greater than. Does that make sense? Now what you see is I have 4 areas. 1, 2, 3, 4. Is that correct? Let me tell you my areas. My areas on this one is a negative infinity to a negative 1 parentheses. Notice they're both in parentheses because it's a dashed line. This area is from a negative 1 to 2, and it's parentheses because they're dashed line. Greeley, are you following this?
Yes.
So what would this area be, Greeley?
Parentheses -2, or just 2 to 6.
Thank you. And the last area would be what, Joss?
6.
To infinity. All right, here's the bad thing, guys. I got to test all of these areas. And I don't test them on the equal, I test them right here. All right, so I have to choose a number from each one. Okay, so I have to put 4 numbers in. So I'm going to start with a -2. Can you see that -2 is clearly in that area, right?
Yes.
And so what I do is, and guys, when you test a -2, here's what you do. You just get a plus or minus, okay? So you have a -2/3, right? Minus 1 over, if that's a -2 minus 4, that's a -4, correct? Is less than a -2 plus 1 is a -1 over 4. Is that true? Okay, let's take a look now. Did everybody see how I did that? Okay. So I have a -2/3 plus 1/4. Is that less than a -1/4? Well, I got to get a common denominator here, don't I? So that would be what? 12, and that would be -8 twelfths plus 3 over 12, right? And is that bigger than that? So it'd be a -5 twelfths. Is that less than
Yes.
a -3 twelfths? It sure is. So this area, it works, so I circle it. Okay? All right, let's try another one. Let's put in 0, shall we? Why would I put 0 in?
Easy.
It's easy. So I put 0 in, I get 0 minus -1/2, is that right? Is less than 1/4. Is 1/2 less than 1/4?
No.
No. Cross it off. I'm going to put in 3. And the reason I'm going to put in 3 is because 3 over 3 is 1. That's the only reason I'm putting it in. Is that okay? I could put 3, 4, 5 in. So I put 3 in, and I get 1 minus 1 over 1 is less than 1. And 1 minus 1 is 0 less than 1.
Yes.
All right.
Yeah.
So this works.
Could you put like 2 or something?
I could have put, no, I can't put 2 because it's on the line. I could have put 3, 4, or 5 in.
You can't put something that's on the line.
No, no. Clearly in the area.
Could you do something that extended farther than the infinity, like a 10 or something?
Yes.
And that would make
Yes.
sense, so it would do-
Yes. So like this area here, I can use 7, 8, 9, 10, 11, 12, whatever. What do you want to use? What do you want to use? You want to use? How about we use? What would happen if we use 9? Why 9?
9/3 is 3.
Okay, 9 divided by 3 is 3, correct? Minus, and 1 over 7 is less than 9 plus 1 is 10/4, which is 5/2, right? Which is 2.5. So I have 3 minus 1/9, which is 2 and 8/9. Is that great? Is that less than 2.5?
Wouldn't it be,
What's wrong?
wouldn't it be 3 and 1, or 2, over there you have 3 minus 1/9, so it'd be 3 minus 1 is 7.
Oh, it'd be 1/7. That's a 7. Yeah. So it'd be 2 and what? 6/7? Is that right?
It's still
It's still not less, is it? So we throw that out. So my answer is a negative infinity to a -1 and 2, 6 union. Okay? That's my answer.
So is that like, can they go on a graph?
What's that?
This whole thing.
Yes, this is not very fun. Not gonna lie to you.
so many opportunities just to mess up.
There's a lot of opportunities, but also on the test, there's a lot of points for it. So, you know what I'm saying? It does add points. Okay? All right, so your assignment is page, cut this down a little bit, page 515, if I could get somebody to go up there and write this. Page 515, numbers 16 through 19, that's the that's the equations, and 25 through 29.
Do tomorrow?
No. No, tomorrow is a work day, and then Wednesday's wind time. Now, Dawson, you're gonna miss the review, but you'll be here for the test. So if you wanna talk about some things on wind time, let me know. Test is Friday. This
I
is
feel
the
like we
last
take
section.
tests
It's
every
today
single
then?
week.
What's that?